Page 302, write an expression. Now, when they talk about an expression, what they're really referring to is an algebraic expression. Yes, algebra, they're referring to that kind of an expression which is going to rely heavily on the use of variables. What are variables? What are variables? Yes. They are letters that usually take the place of a number or a value. Yes, is what variables are. Variables are called that because, yes, they vary. A doesn't always equal 1, nor does B always equal 2. They have different values based on the expression in which we find them. So you might think of an expression as kind of like an algebraic problem that would contain a variable. Now, algebraic expressions can be challenging enough when we know what they are. When we have to put them into language that you understand mathematically and then solve them, it can be quite the challenging task. But kind of like, you know, if you had to do some, who had to do some shoveling yesterday? And the snow was a little heavy, on the heavy side yesterday in certain areas. And you know that if the snow is a little bit heavy and you've got to shovel it, it's probably not a wise idea to try to take a whole lot at once. You take it little by little. So very similar to that is how you're going to attack these problems for today, is when you look at the entire phrase, it can be a little intimidating. But if you separate it, if you break it down, if you take a look at it word by word, it's really not that bad. You need a drink? Go ahead and get a drink. Don't come back in until they're done. Okay? So, if we take a look at guided practice number 1, on the bottom of 302, it says, write an algebraic expression for each phrase, then evaluate given that n is equal to 5. Well, we got to figure out, first of all, what it is that we're trying to do before we can plug in 5 in the place of n. So it says 12.5 more than a number n. So I'm just going to write that up here. Okay, so that's the same phrase that you have in your book. What we need to figure out is, what is that really saying? What problem is that? When you see phrases like, well, obviously you know what 12.5 is. It's a decimal. When you see more than, we think of usually any 4 of their basic operations. Now, does more than, would that qualify as maybe an addition phrase, subtraction phrase, multiplication phrase, or division phrase when you see more than? Alexis? I would agree with you. I would say addition. 12.5 more than a number n. You say n isn't a number, it's a letter. But in this case, it's a variable. It's going to be a number, correct? We already know what n is because they told us that n is equal to 5. Now, there's 2 different ways that you might be thinking. Maybe one way you're thinking. You would think they know what it is. Yeah. No, we said more than. We already said. We can't, don't confuse it and make it something that it isn't. It's written for us right there, more than. So we know it's going to be adding. So I'm going to be adding the 12.5 with what we call n. Des, what is the expression? Okay. Now, on the surface, that is not necessarily incorrect because we're adding, and what do you know about the order in which you add? Does it matter? Is 4 plus 6 equal to 6 plus 4? Okay. Yes, but we need to try to be a little bit consistent. Does this look like 12.5 more than n? Or does this look like 12.5 more than n? If something is more than, you have to have something to compare it to. Okay? I can't say that I have more shoes than Zakiah until I know what? How many shoes she has. Okay? So in order for me to get this accurate and 100% accurate, because it might not matter as much when I'm adding or multiplying, but is order going to make a bigger difference when I'm subtracting and dividing? Can I subtract in any order and have it mean the same thing? No, I can't divide in any order. So I have to work on being consistent with what the phrase is telling me. So this is the expression that we are looking for. Okay? Now, Alexis, you would still get 17.5 if you did it the order that you said. Okay? But technically, okay, this is the combination we're looking for. So you need this, and that'll be for a point, and you need this. That'll be for a point. So 5 plus 12.5, what do you need to remember when you add up decimals? Line them up. If n is equal to 5, line them up. That's how we get 17.5. Okay. Let's just play a little game here. Let's take a look at 2, 3, and 4 and see if we can identify what operations are in each one. Look at number 2. 3.5 added to n multiplied by 4/5. So if I look at number 2, what operation or operations do you see within that phrase? Carlos? Adding and multiplication. Number 3, a number n divided by 2. What do we see? Desi? Division. Number 4, 22.6 less than a number n added to 36.78. That's a subtraction and addition. And it makes sense if more than meant add, then less than has to mean subtract. So you did half the work. You've done half the battle already. You've identified the operations in each of those. So let's take a closer look then at number 2. Closer look at number 2. 3.5 added to n multiplied by 4/5. Okay, let me write it up. Anyone have an idea what they think this might be? I know you're a little scared because the first one you all thought was one way and then I switched it on you. But... Right. Well, 3.5 added to n. Can we take that in the order that it is? Let's use 3.5 plus n, right, added to n times 4/5. Okay. All right, get that down. There is a slight problem with what we have, but it's for a different reason than before. 3.5 added to n multiplied by 4/5. The way we have it written, would we do it in that order? Would I do it in the order that it says in red? Why not, Frank? Order of operations, what would I be doing first? I'd be doing n times 4/5. What can I do to make sure that the first thing I do is add 3.5 to n? What do you think? Anything coming to mind? Edsel? What did you say? Like these. Like these right here. So if I put parentheses around the 3.5 plus the n, that's going to make sure that I add first, because in order of operations, step 1 says all operations in parentheses first. You're in charge of that now. You can do that. We're on 302. Okay? All right, so that's the first point. You'll need that for a point. Now for the second part, we need to find out what the answer is. What was n equal to? 5? Okay. Good. Give it a shot. Okay, if I'm going to add these a mixed number to a whole number, I got to keep them separate, right? So half plus nothing there is going to give me half. 3 plus 5, 8. So now what I have is 8.5 times 4/5. Well, if I'm going to multiply fractions, everything has to be in fraction form. How am I going to put 8.5 into fraction form? Yeah. Which is 16. Very good, Faith. 17 over 2 times 4/5. And then, yeah, we look diagonally, Carlos, and we say 4 and 2 both have 2 in common. There's 1 there and 2 there. 34 over 5. How many times does 5 go into 34? 6 with 4 left. 6 and 4/5. So a point for the expression and a point for your final answer. Okay? We've learned all this, Casimir. We've learned how to add mixed numbers. We've learned how to multiply with fractions. We know the golden rule about everything has to be in fraction form if you're going to multiply. We've done it all. You just didn't hold your hand yesterday and say, hey, this is multiplying fractions. Remember? Here's a refresher. Just jump you right in. Just how math should be anyway. You make a mistake or something? Why are you getting your hands up? 8 goes into 6. If you had 8, and you multiplied it by 1, what would you have? Right? But you're not multiplying by 1, you're multiplying by something else. Frank, what are you saying? Oh, you changed it to decimals. So you should have gotten 6.8. Is that what you got? It's an option 2. Okay. But if you don't even have one full one, you're not even going to get a full 8. Okay? You basically, what is 4/5? It's 80%. Is it 100%? It's less, so you're going to get less as a result. That's how. Okay? You just do it with the numbers the way what should be done with the numbers. It'll all explain itself. So if you don't get the expression right, what are your chances of getting the final answer right? Not very good. You can still get the expression right and miss out on your final answer. Eli. 17 and 1. Well, this was a 17 and 2. 8 times 2 is 16, plus 1 is 17 over 2. Change this mixed number into an improper fraction. Remember we done that? Did that a while back? Number 3. Try number 3. All by yourself. Okay, a number n divided by 2. How am I going to write the expression? N divided by 2. Or, is there another way I could write this? The order has to stay the same. Or n divided by 2. Either way will get you the point. That's an n divided by 2. Either way. Now the advantage to doing it this way is when you plug in the 5 for n, that looks an awful lot like an improper fraction. How many times is 2 going to 5? How many are left? There's your other point. Do we have to set up any division brackets or anything like that? No. Here I will. I have to say 5 divided by 2. So I'd say 2, 5, 2.5. 2.5 the same thing as 2.5? Yeah, so that'll work as well. Okay? I've already gotten both points. Is it right if you try to pawn off 5 divided by 2 as your expression? No. Why? Doesn't have the variable. Not very algebraic if it doesn't have a variable. Then it looks like any problem you did in 3rd grade. Right? So you need a variable in your expression for your first point. Number 4. Try number 4. Just kind of check and see where you are. Some of these are a matter of perspective. Okay? And you may have looked at it and said 22.6 less than a number n and stop there. Or you said 22.6 less than a number n added to 3678. If we stop here, a number n less than a number n added to, we could have n plus 3678 minus 22.76. Now, how many of you had it that way? Anyone? How many of you had it this way? Okay, what's the problem with that, though? What's the major issue there? So if we were to keep it this way, and I would do 5 minus 2276, if I take 22 away from 5, I'm going to end up way in the negative, right? Which is possible. Okay? I'm just not so sure it's going to be the easiest for you. Now, essentially what you'd be doing is subtracting and getting a negative 17.76, and you have negative 17.76 plus 36.78. Let me show you something. If I combine these two, in fact, I could even get it this way. If I have a negative 17.76 and a positive 36.78, I can take, I can take this positive 36.78 and subtract 17.76 and get 1902. 1902 is my final answer. I can still get it doing it this way, but it might be a little difficult. We might not all be there yet. Okay. Now, if we do it this way, and I say, okay, 5 plus 36.78, right? I'm going to get, what, 41.78 minus 22.76. I'm still going to get 1902. So sometimes there's different ways of doing it, but when you're adding and subtracting, you got positives, you got negatives. By and large, your positive values, if you keep them positive, you can move them wherever you want within your problem. Your negative values, if you keep them negative, you can move them wherever you want in the problem. Take, for example, 5 minus 2. And I just took a look at these, and I said, okay, if there's a negative in front of it, you looked at it as a subtraction sign. If it's in front of the number, it's negative. What is 5 minus 2, Dasan? 3. Now let's take these and move them. I want to take this negative 2, and I want to put it in front. What kind of a 5 is this? It's a positive 5. What's a negative 2 plus 5? It's the same thing. It's the same. Did this 5 stay positive? Did this 2 stay negative? So I can move them wherever I want as long as I keep the signs consistent, which is something as you get further along you'll have a better grasp of. Not really fair for you to get it 100% right now. We're just starting with positives and negatives in the first place, but it's all a matter of perspective. You know, you've been taught for a long time that this always just means subtract. They exist by itself in a vacuum, but it's not the only way of looking at it. Anytime you add, you subtract, you're taking one value and you're throwing it up against another value. And when they slam together, you'll get some kind of a result. Same thing here. Okay? Does that really mean 6 minus 4? What else could it mean? It could mean that I took this positive 6 and I slammed it together with a negative 4, and the result was a positive 2. There was 2 left over. If I wanted to rewrite it, does it still give me 2? Okay, so it's just a matter of perspective. All those numbers you've been dealing with, ever since you've been dealing with numbers, I don't want to say you've been lied to, but you just haven't been shown the entire picture. Your eyes are finally open. Number 5 at the top of page 303. That one looks too easy. Try number 8. Number 8. This time n is equal to 8. Try number 8. N is equal to 8. Key word is sum. Tells us 2 things, actually. It doesn't just tell us 1. But 2 things does it tell us? Yes. It tells us that we're going to be, first of all, doing what operation? Adding. And then I need to take the sum, which is the answer to 6 plus 1.28, and then I'm going to divide that by n. So Alexis, let's say that means if I were to leave it as is, would I be dividing the sum by n if I left it like this? No. Because if I were to give you this problem as an order of operations problem, there's no way that you would add before you divide it. Not if you did it right. The only way to ensure that we do the sum divided by n is to put parentheses around it. Now maybe you caught it in your work but didn't catch it here, then you'd miss a point. You need the parentheses. Because when I add these together, I'm going to get 7.28 divided by the 8. Now divide the sum, 6 plus 1.28 divided by 8. Okay, is that possible? Sure it is. Put 8 on the outside, 7.28 on the inside. Bring the decimal up. Is 8 going to 7? Is it going to 72? Is it going to 8? So my final answer is 91 hundredths. A couple of the guys got the 91 hundredths. Anyone else get it? Got it? Oh, you used 5. But you had it set up. You were going to do that. Okay, good. Catch. Where'd you learn that trick?
Well,
Board? Okay, here's the deal. We're going to do worksheet 12-1, numbers 1 through 20. Just kidding. Here's the deal. You've got about 7 minutes before you're going to be dismissed for your next class, maybe 5. All I want you to do for tomorrow is to complete any 2 of them. That means the expression and the answer. For every person I see talking or hear talking, I'm going to add another one. Then it'll be 3 you got to pick. Then it'll be 4. Then it'll be 5. For every person that comes back for help, add another one. I'm not doing this for, all I'm asking for is 2. You can pick any 2 you want from 1 through 20. You should be able to find 2 in there that everybody can do. What is n equal to on the worksheet? 12. Okay? Pick 2.